Okay, I pretty much nearly finished this question and someone banged on the door, so I'm going to have to start it again. Okay, so if the video's all a bit all over the place, or you've got loads and loads of videos because people keep banging on the door now. Right, so this is an isosceles trapezium. That just means it's got some symmetry to it. Okay, so the bottom angles are the same. It means I can set an equation there. I've also got other information up here with this other bit here. This has got a y in it, so I've got x's on the bottom, so I can actually solve x by setting up an equation because these two are equal. So I can set an equation there. I can't figure anything out for y yet, just having this, so I need to find x first. So that's what I'm going to try and do. So if the base angles are equal, I can set this equation. So 2x plus 40 equals 4x minus 30. We've got x on both sides, so the best thing to do is eliminate the smallest value of x. So I'm going to eliminate 2x by taking it away. That leaves 40 equals whatever we get. So 4x take away 2x. So both sides are decreased by 2x minus 30. Then I'm going to add 30 to eliminate the negative 30. So 70 equals 2x. And then I'm going to divide by 2 to get rid of the 2 to make x by itself to get 35. So now x is 35. Okay. Now the thing about trapeziums is there's always one feature that's true, is that these two lines have to be parallel for it to be a trapezium. Okay. So when things are parallel, there's a relationship between the angles with the lines that touch them. So this line is touching both of these parallel lines. So there's a relationship between these two angles. Okay. These are on the inside of this line. If this was a full picture, this line would be extended, the line would be going all the way through. These two angles are on the inside of that, inside of the parallel lines, and on the same side. They're called interior angles, okay, or supplementary angles. So these are co-interior angles. They both add up to make 180 degrees, okay. So it doesn't ask me to write that down. It doesn't say give you reasons, but this is what the reason is. They are interior angles. They are the same, okay, co-interior. So they add up to 180, sorry. So 3x minus 5y, which is the top angle, add 4x minus 30 equals 180 degrees. So these two equal 180 degrees. I think x is 35, so I'm going to eliminate the x now. So 3 times 35, take away 5y, plus 4 times 35, take away 30, equals 180. Let's see what we've got. 3 times 30 is 90. 3 times 5 is 15, so that's 105. Take away 5y plus, when you times by 4, you can double it, then double it again. So double 35 is 70, double that again is 140. Minus 30 equals 180. All right, lots going on there, so I'm just going to sort of collapse some stuff together. So 105 add 140 is 245. Take away 30 is 215. So 215 take away 5y equals 180. Now I can start solving it. This is the reason why I'm saying I'm quite long-winded. I'm showing you every single step here. Some people will probably miss bits and bobs out, but I don't think it's a benefit to keep skipping different things. So let's have a look. And back my way, you can see everything that's going on, and the examiner can as well. And it's worth 5 marks, so you've got to justify things clearly. So I'm going to solve this. I'm going to take away 215. So minus 5y is 180 take away 215. So it's going to be negative. So a way to get around that, because some of you won't be confident, if you take it away this way, you'll know the gap between them, and that's how far down into the minuses it's going to go. So 5 take away nothing. Can't do 1 take away 8, so I'm borrowing. And 1 take away that. So this is minus 35. I'm going to divide by 5. So minus y equals 35 or minus 35 divided by 5, which is minus 7. And I don't like that. I'm going to flip the signs of both of them. I don't want negative y. I've just flipped the signs. Now I could have divided by minus 5 all in one go, but I like to see this, or I like to show this often, because people don't always get rid of the minus at this step. They do leave a minus y, so I need to show you what you do when that happens. I mean, up here I could have changed the signs of all of them straight away, and that could have avoided doing that at some point. So x is 35 and y is 7. Okay, so it's a good question. It's an unusual question. because you have to think about what you're going to do with it. But there we go. Right, so number 9. There we go. Write the numbers in order of size. Start with the largest. So these values are not even in the same format. Some of them are in, well, they're not. None of them are in any sort of format. They look like standard form, but they're not. So I'm just going to try and change these all to ordinary numbers. So 0.067 times 10 squared. That's actually 100. So this decimal place is going to, well, the numbers are going to shift to the left too. So it's going to be 0.067. So it's going to go. So that is actually 6.7. This one can stay at 67. Right, this one, if you've got the idea that this has moved 2 places to the right because it's a squared or a positive 2, this idea is that it's a negative 1. So it's going to go the other way. I'm actually dividing by 10. Okay, so that's actually going to move this way 1 place. So it's 0.067. And this one is minus 4. So decimal point currently is at the end there. And it's going to go 4 places that way. So 1, 2, 3, 4. So 0.67. I don't need the zeros. So the largest was 67 by itself. Okay, and the next one is obviously 6.7. So the original one was that. So I'm going to put the original. So 0.067 times 10 squared. So that's these two. And then I've got 0.67. So 6700 times 10 to the minus 4. Done. And then the last one is that 0.67 times 10 to the minus 1. Okay, so it's a weird one. But if you're happy with like changing numbers in and out of standard form, that would probably be okay for you. It's the same process, same idea. Okay, powers. Powers sometimes are just powers, but sometimes they're codes. So this is a code. So a negative power is code for 1 over. So if I got rid of the negative and just made it squared, it would just be 4 squared, but the negative means 1 over. So now I've got rid of the negative by doing 1 over. It's 1 over 4 squared. And then 4 squared is 4 times 4, so it's 1 over 16. Okay, so it is nice and straightforward, but powers are codes. So negative power, which I'll do like that. I've chosen the wrong thing. So the negative part just means 1 over. Okay, and the base stays the same and the power stays the same, but the 1 over is code for the negative 1. Okay, this bit, surds. When you see a surd, you need to write down your square numbers. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So what I need to do is find one of these that fits into 63. And the biggest one, really. So the next one of this would have been 49, it's been 81, so it can't be that. 49 don't fit into it, 36 doesn't, 25 doesn't, 16 doesn't, 9 does. It's 9 times 7. 9 is a square number. That's what we were looking for, square numbers. So that can be square rooted. And if we square root 9, it becomes 3. We can't square root 7, so that stays as root 7. So when it says write root 63 in the form of k root 7, you can see 7, that's where it's come from. And it's the whole value, the integer, is 3. Okay, so that is